two natural numbers, p and q, do not end in 0. The product of any pair, p and q, is a power of 10. That is 10 or 100 or 1,000 or 10,000 and so on. If p is greater than q, the last digit of p minus q cannot be. Okay, so let's try to understand the question before we tackle the question. P and q do not end in 0. All right, so that means p cannot be 10, p cannot be 20, that kind of thing. The product of any pair, so if you multiply p and q, it's going to be a power of 10. So 10 to some power. We don't know what power. And then they're telling us that p is greater than q, and they want us to figure out p minus q, and then say what is the last digit of this number. So the first thing I noticed is not much information given, but we can work with this. 10 to the power of n is broken up into 5 and 2, like that. And since p is greater than q, p I will let equal to 5, and q I will let equal to 2, like that. So this becomes 5 to the n times 2 to the n. And then what we have to do is we have to make a table and see what we get. So we're going to make a table for p, for q, and then p minus q, which is what we've been asked to find, for values of n. And the hope with these style of questions is that you're going to get some sort of pattern, and that pattern will help you greatly. And sometimes the pattern comes pretty quickly, and sometimes the pattern takes absolutely forever to get to. It depends on the question, but I'm anticipating that since this is a grade 7 contest, the pattern will come relatively quickly. All right, so when n is 1, we have p is 5 to the power of 1 right here, which is just 5, and q will be 2 to the power of 1, which is just 2. You see how I got that? When n is 1, p is 5 to the power of 1, and q is 2 to the power of 1. So those are the values for p and q. So p minus q is 3. And therefore, what is the last digit, which is what they're asking for? The last digit, it's just 3. Now let's try n equal to 2. When n is 2, p is 5 to the power of 2, which is 25, and q would be 2 to the power of 2, which is 4. P minus q is therefore 21, and the last digit of this number is 1. All right, so far so good. Let's keep going here. When n is 3, p is 5 to the power of 3, which is 125, and q is going to be 2 to the power of 3, which is 8. And therefore p minus q is 125 minus 8, which is 117. 7 is the last digit. When n is 4, p is 5 to the power of 4, which is 625, and q is going to be 2 to the power of 4, which is 16. And 625 minus 16 is 609, and therefore the last digit is 9. Now I want to stop here and go back to the question. The last digit of p minus q cannot be. I think we've done it so far. We have a 3, so it can be 3. We have a 1 here, so it can be a 1. We have a 7 here, so it can be a 7. And we have a 9 here, so it can be a 9. The only one it cannot be is 5. But I just want to do a few more because I like to torture myself. So just a few more. So n is 5, so we got 3, 1, 2, 5, and this is 32. So this would be 3093. The last digit is 3. If n is 6, we'll have 15625, and this is 64, and therefore this is 15561. Last digit is 1, and I'll do 2 more. When n is 7, this is 128, and p minus q becomes 8. Last digit is 7. And finally, one last one. 256 for q, and p minus q, and the last digit is 9. So again, this was 3179, and this is also 3179. So you see there's a pattern that keeps repeating, and that's what I was looking for. But like I said earlier in the question, we already figured it out. The only choice that it cannot be is 5. So the answer is C.